Hello everyone. I welcome all of you in my last lecture on heat and mass transfer of the first unit. So today we are going to finish the first unit of heat and mass transfer subject. Actually, today this class I just prepared only of revision classes because all the topics of the first unit we already discussed. We discussed each and every concept of heat and mass transfer. We have derived, for heat transfer for slab, for cylinder, for sphere, for composite slab, for composite cylinder, for composite sphere. Then we have discussed electrical analogy, thermal resistance of slab, thermal resistance of cylinder, thermal resistance of sphere, composite slab, composite cylinder, composite sphere. So all these parts we already discussed. Okay, there is nothing left. Now this total class I just today's lecture I prepared only to revise the recall all the things at a time so that it help you further because this particular heat and mass transfer subject it really help you in in your higher studies. There is gate exam is there, or in any competitive exams if you see there in syllabus heat and mass transfer, definitely it will be there. So this is very much I'll really advise you that you must follow each and every videos of my heat and mass transfer, and stick hard with these videos, and try to listen each and every words of this of the videos so that you understand the minute concept of minute concept of the heat and mass transfer, because to solve any time with numericals we need concept. If you don't have concept we can't solve. But here in each and every videos I have explained the concepts well, so you just listen to the videos and try to grasp the concept so you can solve any kind of numericals on heat and mass transfer. If you open any gate question paper, if you want to solve the gate question paper on heat and mass transfer topic, you can solve any type of numericals with the help of my videos. So without wasting time, just we'll go forward. So here is a revision. General heat conduction equation and Cartesian coordinates. I'll just try to read out the first. Delta 2t del x2 plus delta 2t by del y2 plus delta 2t by del z2 plus qg by k equals to 1 by alpha delta t by del t. Now, general heat conduction equation in cylindrical geometry, the formula is 1 by r square delta 2t by del phi 2 plus delta 2t by del r2 plus 1 by r delta t by del r plus delta 2t by del z2 plus qg by k equals to 1 by alpha into delta t by del t into dt. Next, general heat conduction equation in spherical coordinate is delta 2t by del r2 plus 2 by r delta t by del r plus 1 by r square sin square theta delta 2t by del phi 2 plus 1 by r square sin theta del theta of sin theta delta t del theta plus qg by k equals to 1 by alpha delta t by del t into dt. Next, one dimensional steady state no heat generation heat transfer through slab. The formula Q equals to K into A T1 minus T2 by L. Next, one dimensional steady state no heat generation heat transfer through cylinder. The formula Q equals to 2 pi KL T1 minus T2 by ln of R2 by R1. Next, one-dimensional steady-state no heat generation heat transfer through sphere. Q equals to 4 pi k R1 R2 into T1 minus T2 by R2 minus R1. Next, heat transfer through composite slab. The formula Q equals to Ti minus T naught by 1 by Hi plus L1 by K1A plus L2 by K2A plus L3 by K3A plus 1 by H naught. And the value of overall heat transfer coefficient U equals to 1 by Hi plus L1 by K1A plus L2 by K2A plus L3 by K3A plus 1 by H naught. And heat transfer through composite cylinder, the formula Q equals to 1 by T1 minus T naught by 1 by HIAI plus a lot of R2 by R1 divided by 2 pi K1L plus ln of R3 by R2 plus 2 pi K2L plus 1 by H naught A naught. And overall heat transfer coefficient based on inside UI equals to 1 by HI plus R1 into ln of R2 by R1 by uh, 2 pi K1L plus R1 ln of R3 by R2 by 2 pi K2L plus R1 by R3 H naught. Similarly, U naught will be 1 by R3 by R1 HI plus R3 ln of R1 R2 by R1 by K1 plus R3 ln of R3 by R2 by K2 plus 1 by H naught. Similarly, next heat transfer through composite sphere. The formula Q equals to Ti minus T naught 1 by HI AI plus R2 minus R1 by 4 pi K R1 R2 plus R3 minus R2 by 4 pi K2 R3 R2 plus 1 by H naught A naught, and U naught Uy equals to 1 by HI plus R1 R2 minus R1 by K1 R2 plus R2 square R3 minus R2 by K2 R3 R2 plus R1 square by R3 square H naught. Similarly, overall heat transfer coefficient based on outside U R naught equals to 1 by R3 square by R1 square HI plus R3 into R2 minus R1 by K1 R1 R2 plus R3 into R3 minus R2 by K2 R2 plus 1 by H naught. And next, last topic, we discussed electrical analogy. So there we discussed thermal resistance of single slab R equals to L by Ka, composite slab R equals to L1 by K1A plus L2 by K2A plus L3 by K3A. Thermal resistance of cylinder R equals to ln of R2 by R1 by 2 pi KL. Similarly, for composite cylinder, R equals to ln of R2 by R1 by 2 pi K1L plus ln of R2 by R3 by R2 by 2 pi K2L. And last, you see, thermal resistance of sphere R equals to R2 minus R1 by 4 pi K R1 R2, and thermal resistance of composite sphere R equals to R2 minus R1 by 4 pi K1 R1 R2 plus R3 minus R2 by 4 pi K2 R3 R2. So up to this was the revision of the first unit. So if you understand or grasp the concept of the first unit, I hope you will be able to solve each and every numericals on heat and mass transfer. So I have given some numericals on heat and mass heat transfer. These are some gate-based numericals. So these numericals I have given. You try to solve these numericals in your free time, in at room. I hope you will be able to solve these numericals. Okay. Okay. Thank you. So in the next lectures again we'll come back. Again we'll come back with our second units. So till then, okay. Thank you.